Bismillahirrahmanirrahim. Start with the name of Allah Almighty, who is the most beneficial and merciful. First of all, I want to say Assalamu alaikum to everyone. I hope that all of you will be fine. So dear friends, today in this video we are going to solving the third portion of the exercise set 1.1 of the calculus with analytical geometry. The third portion of the exercise set 1.1 is said that draw the graph of the following functions. In a third portion, we will draw the graph of the functions. So just I will solve only one question of the third portion, and the other questions of the third portions you will solve yourself. I hope that after seeing this video you will be able to solve the other questions of the third portions. So first of all, we are going to question number 23 of the third portions of the exercise set 1.1 of the calculus with analytical geometry. First of all, we are going to read and write the statement of the question number 23. The statement of the question number 23 is given that draw the graph of the following functions. Question number 23, f of x, which is equal to absolute value of x plus absolute value of x minus 1 for all x belonging to R. First of all, the given function is that f of x, which is equal to absolute value of x plus absolute value of x minus 1 for x belonging to set of the real numbers. So we know that the given function contains absolute values. So when the function contains absolute values, then there are three conditions. So the first condition is that when the x is less than 0, then we take the values of both x will be negative. When the x is greater than or equal to 0 or less than or equal to 1, then we take the one value of the x is positive and the other value of the x is negative. The third condition is when x is greater than 0, then we take the both value of the x is positive. So the first condition is that when x is less than 0, then we take the both value of the x in a given function is negative. So the function values is f of x, which is equal to minus x plus 1. The answer of the minus x will be minus 2x plus 1. We write plus 1 at the first and minus 2x at the second. So we know that when f of x, which is equal to 1 minus 2x, then y is equal to f of x. So then y which is equal to f of x, then y which is equal to this function, y which is equal to 1 minus 2x. It is because we have already know that y which is equal to f of x. So when f of x which is equal to 1 minus 2x, then y which is equal to 1 minus 2x. So the second condition is that when x is greater than or equal to 0 and less than or equal to 1, then we take the one value of the x is positive and the second value is negative of the functions. So the function is a f of x, which is equal to x minus x plus 1. We take first x is positive and the second x is negative. So positive x and the negative x cancel each other, only left 1. When f of x which is equal to 1, then y which is also equal to 1. The third condition is that when x is greater than 0, then we take the both value of the x is positive. So the function is f of x which is equal to plus x minus 1. We take both value of the x is positive. It is because that this is the third condition. Third condition, which is that x is greater than 0. So the answer of the plus x will be 2x minus 1. When the f of x which is equal to 2x minus 1, then y which is also equal to 2x minus 1. So now we are going to solve the graphing values of the given functions, which is applied on these three conditions. First of all, we determine the graphing values, and after, with the help of those values, we will draw a graph. So for our first condition, when y which is equal to 1 minus 2x, then these values, when we put x which is equal to minus 1 by 2 in this equation, then the y becomes 2. When we put x which is equal to minus 1 in this equation, then the y which is equal to 3. When we put x which is equal to minus 2 in this equation, then the y will be 5. For a second condition, when y which is equal to 1, then x will be 0. When x will be 0, y which is equal to 1. When y which is equal to 2x minus 1, there are the following values. When we put the value of the x is 3 by 2 in this equation, then the value of the y will be 2. When we put the value of the x is 2 in this equation, then the value of the y will be 3. When we put the value of the x is 3 in this equation, then the value of the y will be 5. So now, with the help of these values, we draw the graph of the given function. First of all, the graph of the given function is that this is the x-axis, this is the x-axis, and this is the y-axis. So for the first equation, the value of the x is minus 1 by 2 and y is 2. The value of the x is minus 1 by 2 and on the y is 2. We put a dot. These are the values are minus 1 by 2 on the x-axis and 2 on the y-axis. If we are going to x-axis, then the value of the x is minus 1 by 2. So we put the dot. In that, the front of the y-axis, when the value of the y is 2. So we put the dot on the x-axis and y-axis. So these are the values minus 1 by 2 and 2. As the same way, when we put the value of the y will be 1, then the value of the x is 0. This is a dot. When the value of the x is 0, then the value of the y will be 1. And for third equation, when the value of the x will be 3 by 2, then the value of the 2 will be y. Or the value of the y will be 2. For a third condition, the value of the x is 3 by 2. This is a 3 by 2. And the value of the y is 2. This is a 3 by 2 and this is a 2. We put the dot. And when the value of the x is 2, then the value of the y will be 3. The value of the x is 2 and the value of the y is 3. When the value of the x is 3, then the value of the y will be 5. when the value of the x is 3, then the value of the y will be 5. So in this way, we draw a graph. This is a graph of the given function. I hope that all of you would have to understand the lot of concept of third portion of the calculus with analytical geometry, and I hope that all of you will be able to solve the other questions.